In this video, we'll learn how to divide polynomials by using long division. So here on the screen, you can see that we have two polynomials. We have 2x squared minus 2x minus 60, and we're going to divide that by x plus 5. Now that might sound really complicated, but it's actually a little easier than you might think. So the first thing I like to do is set it up so that I can look at it as a division problem or a polynomial division problem. So I write 2x squared minus 2x minus 60. If you've ever used long division, you've probably seen this format before. And we're going to divide that by x plus 5. Now what we're going to do from here is we're going to focus on this term by term. So I'm going to first focus on this piece here. And essentially my goal is going to be to eliminate each term while I divide. So what I'm going to do is I'm going to take 2x squared, that first term on my inside polynomial there, and I'm going to divide it by the first term in my other polynomial, which is x. Now, remember that the coefficient of x here is just 1. So essentially what we're trying to do is we're trying to figure out x times what will give me that 2x squared. And so here if I take 2x squared divided by 1x, I'm going to get 2 divided by 1 is 2, and then x squared over x to the first, we just subtract their exponents and we get 2x to the first, or just 2x. So what that's telling me is 2x times 1x will give me 2x squared. Now this 2x here, believe it or not, is the first part of my answer with my division. And so what I'm going to do at this point is, now that I know that I need to have 2x times x in order to eliminate that 2x squared, is I'm going to take this 2x here and I'm going to multiply it by both x and 5. So if I take 2x times x, I get 2x squared. And then if I take 2x times 5, I get a positive 10. Now from here, you have two options. You can either subtract this blue piece from the red piece above it, or you can distribute this negative 1 here, and then you'll have negative 1 times 2x squared, which gives you a negative 2x squared, and negative 1 times 10, which gives you a negative 10x. And so once you've done that, then what you can do is you can just add these two rows together instead. Now, if you'd like to subtract, that's okay. I just think it's a little bit easier to distribute the negative 1 and then add straight down. So if I do 2x squared and negative 2x squared, that gives me 0x squared. So you can see that my x squareds in my red polynomial have been eliminated. Negative 2x minus 10x gives me a negative 12x. And then negative 60 has nothing to, add or subtract from it. So that's just going to be a negative 60 transferred down. So that's our first step in polynomial division. And now we're just going to repeat that process until we have basically run out of terms. So the next thing I'm going to do is I'm going to look at what's left, and I'm going to look at the first term, and that's negative 12x. And I'm going to divide that by the first term in the polynomial I'm dividing by, which is just a 1x. So negative 12x divided by 1 gives me negative 12. X divided by x, that cancels out. And so there's no variable on that 12. I just need a negative 12. And so now this second piece of my answer, what I'm going to do is I'm going to take a negative 12 and I'm going to multiply it by both x and 5. So I take negative 12 times x, which is a negative 12x. And then I take negative 12 times 5, which is a negative 60. And then from here, what you kind of need to remember is that we're going to be subtracting this second piece here. So we're going to subtract this out. Now remember, if the subtraction confuses you, you can distribute this negative 1. So that would be negative 1 times negative 12, which is a positive 12x. Negative 1 times 60, which is a positive 60, and then instead you can add straight down. So now we can take negative 12x plus 12x, which is 0x, and I can take negative 60 plus 60, which is 0. Now, if you notice here, 0x plus 0, that really equals 0. And what that means is that our division problem is over. And essentially what we've discovered is that if we take that first term that you saw there, if we take negative 2x squared minus 2x minus 60, and we divide it by x plus 5, we're going to end up with an answer of 2x minus 12, which you can see stored in a couple of places. It's above here, or it's these two terms I found along the side. Now, another way to think about this and another way to check your answer is what this division problem really tells you is that x plus 5 times 2x minus 12 is going to equal 2x squared minus 2x minus 60. That's what you've really found. You found what times x plus 5 is going to give me this polynomial. So that's one way, if it works out nicely, for you to be able to check your answers afterwards. So now let's go ahead and let's try a second example. So again, I'm going to write out my long division notation here, and I can see I'm going to put the ones in, 1x to the third minus 1x squared minus 2x plus 8, and I'm dividing that by x minus 1. So we're going to go ahead and we're going to now divide these together. So remember, we always start term by term. So I'm going to take 1x to the third, and I'm going to divide it by this first term here in that second polynomial, which is just a 1x. Well, 1 divided by 1 is just 1, and then this is x to the third over x to the first, and if we subtract those exponents, we end up with 1x squared. So I know that the first piece is a 1x squared. Now what I'm going to do here is I'm going to take this term value, and I'm going to multiply it by my x minus 1. So 1x squared times x is going to give me 1x to the third. And then 1x squared times negative 1 gives me negative 1x squared. Now remember, we are subtracting this bit, and so the easiest way to go about this is to distribute this negative 1. So negative 1 times 1 is a negative 1x to the third. Negative 1 times a negative 1 gives me a positive 1x squared. So now what I can do is I can simply add straight down. So what I notice here are that 1x cubed and negative 1x cubed gives me 0x cubed, so my x cubes are gone. Negative 1x squared plus 1x squared gives me 0x squared, so my x squareds are now gone. And then these last two terms have nothing to be added with them, so they just transfer straight on down. Now you'll notice in that particular problem, we were able to eliminate two terms at once. That doesn't always happen, but it's really nice when it does. So now I'm going to focus in here on the negative 2x, and I'm going to take negative 2x and divide it again by this first term, which is a 1x. So I take negative 2 divided by 1, which is negative 2, and then the x's cancel, so it's just minus 2. And then I take this minus 2 and I multiply it by both terms over here. Negative 2 times x is a negative 2x, and negative 2 times negative 1 is a positive 2. So now from here, just like before, we're going to subtract this. Now, remember, the tricky part about this is you need to be careful with that subtraction. I like to distribute my negative 1s out. So negative 1 times negative 2, x is a positive 2x. Negative 1 times a positive 2 is a negative 2. And then if I do that, I can add straight down instead. So negative 2x plus 2x gives me 0x, so my x term is gone. 8 and negative 2 gives me a positive 6. So now I still have this positive 6 to worry about. And so what I can do is I can now test that one out, and I can take 6 divided by that first term, which is x. Now, I can see here that there's no simplifying that can take place. And as a result, what's really happening here is instead of continuing to try to divide, we have what is called a remainder. And how we write our answer when we have a remainder is we still take these two values that we found here because those are still important. Our division problem is going to have 1x squared minus 2 as its answer. But then we have to keep that and take that remainder and put it into our answer. And the way that we put that remainder into our answer is we take plus and we put that 6 over what we were dividing by to start, which you can see in a couple spots in this problem. You can see it's here too. We're going to take 6 and we're going to divide it by what we were dividing by at the start, which is x minus 1. So our final answer here is going to be 1x squared minus 2, because that's what divides nicely, plus 6 divided by x minus 1, because that's our remainder piece in our answer. All right, let's solve one more problem that's a little bit more complicated. So here we can see that we're going to divide two polynomials. Our first one is 2x to the fourth plus 3x cubed. Then from here, I notice that I'm missing an x squared term here. There's no x squared term in the problem. And in order to be consistent and be careful here, we need to add in a plus 0x squared just to make sure that we don't miss that any x squared terms that might appear later on. Then we have plus 5x minus 1. And what we're doing is we're taking that polynomial and we're dividing it by x squared plus 3x plus 2. So you can see there's more terms here, and this one is just a little bit more complicated. But luckily, the process is still the same. So we're going to start with this first term here, which is 2x to the fourth, and we're going to divide it by that 1x squared, because that's the first term in the polynomial we're dividing by. So 2 divided by 1 gives us 2. X to the fourth over x squared. We subtract those exponents and we get x squared. So that's the first piece of our division problem answer, is we have 2x squared. So now we take 2x squared and we're going to divide it by all three terms here. So 2x squared times x squared, that's going to be 2 times x to the fourth. Notice we had x squared, the 2's get added together. Then we take 2x squared times 3x, so 2 times 3 is 6. And then we take x squared times x, which is x to the third. And then we take 2x squared times 2, which is 4, and x squared. So we can see that we have three terms here that we need to focus on subtracting with. So we're going to subtract this term. Now, as I said before, that subtraction can get tricky, so I like to distribute that negative 1 out and add. So this would be negative 2x to the fourth minus 6x cubed minus 4x squared, and then I can add straight down. So I take 2x to the fourth and negative 2x to the fourth, that gives me 0x to the fourth. 3 and a negative 6x to the third give me negative 3x to the third. 0 and negative 4 give me negative 4x squared. And then these final two terms just come right on down with the problem because there's nothing to add or subtract with. So then we take a look at the next term in this problem. This one is gone, so we're looking at the negative 3x to the third. So we're going to take negative 3x to the third, and we're going to divide it by the first term here, which is 1x squared. Well, negative 3 over 1 is a negative 3. If we subtract those exponents on the x's, we get negative 3x. And so now we're going to take negative 3x and multiply it by all three terms here. So negative 3x times x squared gives me a negative 3x to the third because I add those exponents of 2 and 1 together. Negative 3x times negative 3x gives me a negative 9x squared. And negative 3x times 2 gives me a negative 6x. So now from here, again, we're looking at how do we combine these together. Well, we're going to subtract that entire polynomial, which means I'm going to take my negative 1 and distribute it, and then add. So negative times a negative becomes a positive 3x cubed. a positive 9x squared, and a positive 6x. And then I can add, since I distributed that negative 1. So negative 3x cubed plus 3x cubed, that gives me 0x cubed, so those are gone. Negative 4x squared plus 9x squared gives me a positive 5x squared. Then positive 5x plus 6x gives me a positive 11x. And then this negative 1 just carries down as a part of the problem because it has nothing to subtract with. So that's now out of the problem, and my new term to focus on is right here. So I have 5x squared divided by x squared, which is again my first term out here. So I'm just repeating this process over and over and over again. So 5 divided by the 1 is just 5. The x squareds cancel out, and so the next piece of my answer here is just 5. So I'm going to multiply all 3 of these terms by this 5 over here. So 5 times x squared is 5x squared. 5 times 3x is 15x. And 5 times 2 is 10. So what I'm going to do here is I'm now going to subtract that second polynomial. And again, remember, the easiest way to do that is to distribute that negative 1 and add. So we have negative 5x squared, negative 15x, and a negative 10. So now that I've distributed it, I can add down instead. So positive 5x squared plus negative 5x squared, that gives me a 0x squared, so that's really out of the problem. 11x minus 15x, that's a negative 4x. A negative 1 and a negative 10 is a negative 11. So I am getting closer to my final answer, but I'm just not quite there yet. So we're going to again look at this problem. So we look at the first term. So I have negative 4x divided by x squared. And when I try to simplify this, I notice, okay, the negative 4 and the 1, those can simplify to be negative 4. But because there's more x's in the bottom, even if I subtract those exponents, I end up with an x to the first in the bottom. So the second you're ending up with x's in the bottom of the fraction here that you're trying to divide by, this is a key sign that you're not going to be able to divide further. And instead, whatever is remaining, that negative 4x minus 11, that's our remainder piece. So we're going to have to write a remainder instead. So we are done with this problem. We just need to tie some of the key components together. So our final answer, the first piece, can be found right here and right here. So the first part of our answer you can see is 2x squared minus 3x plus 5. Those are the values that we found as we were dividing. Then we have a remainder, which we can see right here. It's whatever is left, negative 4x minus 11. And then we put that over what we were dividing by the whole time, which is x squared plus 3x plus 2. So there you have it. A little bit longer of a polynomial division problem, but same concept and can easily be done.